The second video you're about to watch is all about how to predict solubility. We're going to use what we learned in the first video to determine if two substances are going to be dissolved. So the first one is, will butane C4H10 dissolve in carbon disulfide CS2? So the first thing we have to do is figure out how many valence electrons there are in butane. Each carbon atom has 4 valence electrons, there's 4 of those. Each hydrogen atom has 1 valence electron, and there's 10 of those. So the total is going to be 26 valence electrons. So C4H10 is called a hydrocarbon. Typically these are in links or in rings, and our final Lewis structure is going to look like this. A whole bunch of C's linked together with some H's surrounding them. This compound is super symmetrical. There's actually no lone pairs on this structure at all, which means it's going to be nonpolar. Then we have to take a look at carbon disulfide as well. Again, carbon has 4 valence electrons, and there's 1 of those this time. And sulfur has 6 valence electrons, and there are 2 of those. So the total is going to be 16 valence electrons. Our structure for CS2 is going to look like this. We have to have a couple of double bonds so that we can have only 16 valence electrons, but still having the full octet of carbon and both sulfurs. So when you look at this structure, the central atom has no lone pairs, which means each of the dipoles from the sulfur and the carbon are going to cancel each other out. This is a nonpolar substance. There's no lone pairs on the central atom. So that means that yes, C4H10 will dissolve in CS2 because like dissolves like. Nonpolar compounds will dissolve other nonpolar compounds. Because they're both nonpolar, that butane will dissolve in carbon disulfide. The next question we're going to look at is cesium chloride, CsCl2, and when it is added to hexane, will it dissolve? So cesium chloride is going to be an ionic compound because cesium is a metal and chlorine is a nonmetal, which means we have an ionic compound. Then we have to look at hexane, which is 2 nonmetals bonded together, which means we have to draw the Lewis structure to determine if it's polar or nonpolar. So C6H12. There are 4 valence electrons in every carbon. There's 6 of those, plus 1 valence electron in each hydrogen. There's 12 of those. So our total value is 36 valence electrons. There's no other way to put hexane together and give every single element a full octet without creating a ring. And I know it looks kind of overwhelming, but we have a ring of 6 carbons, and each carbon has 2 hydrogen that are hanging off of it. This structure is very symmetrical. Everything about it is perfectly symmetrical. And there's not even 1 lone pair. So we know that this substance is going to be nonpolar. So the question is, will an ionic compound dissolve in a nonpolar compound? The answer to that is no. Ionic compounds are very much like polar compounds and not at all like nonpolar compounds. So like dissolves like is going to tell us that this doesn't work here. Ionic compounds will not dissolve in nonpolar compounds. So if cesium chloride will not dissolve in a nonpolar compound, will it dissolve in water, a very polar compound? And the answer to that is yes. CsCl2 is ionic and H2O is polar. Ionic compounds do dissolve in polar solvents. And the reason for that is because ionic compounds are very similar to polar compounds. One side is positive and the other side is negative. The last example that we're going to look at is ethanol. Ethanol is also a hydrocarbon, but you notice it also has oxygen hanging off the end of that. So we'll draw the picture or the structure anyway. Every carbon has 4, there's 2 of those. Every hydrogen has 1, there's actually 6 of those. And each oxygen has 6, there's 1 of those. So our total value of valence electrons is going to be 20 valence electrons. And this is what your structure is going to look like. In this structure, you'll notice that most of the compound does not have lone pairs. However, that oxygen does have lone pairs. That causes the electrons to stay more by the oxygen than the rest of the molecule. This uneven sharing of electrons results in C2H5OH being a polar molecule. So we have a polar ethanol molecule, and we want to take a look at water. Water, we know the structure looks just like that, where you have two hydrogens and two lone pairs hanging off your oxygen. What you'll notice is, again, we have lone pairs on our oxygen. Again, that results in unevenly shared electrons. That partial negative and the partial positive from the hydrogens is going to result in water being polar, which we knew already. So, are these two things miscible? Yes. Polar substances will dissolve other polar substances. So, because of that, like dissolves like. Polar will dissolve polar. Yes, water and ethanol are miscible. So, hopefully you found this video helpful. You should use it to assist you with your homework assignment, which is the following pages 12 and 13. Good luck!